In this video, we're going to deal with some percent concentration questions. And so these are from our work booklet, and this is a little hard to see, but it says, what mass or volume of solute is contained in each of the following solutions? Now, percent weight per volume is the mass of the solute over the volume of solution times 100%. But for this to work, we need to have the milliliters of solution and grams of solute. And the reason is that 1 milliliter of water is 1 gram. So for water, this statement is true, so we can make a percentage out of it. Because we need to be comparing sort of apples to apples. We need to have the same sort of thing going on. So here they've got 100 milliliters of a solution, and it's 1.5% weight per volume. What is the mass of the calcium nitrate solute? So if your percent weight per volume is going to be equal to 1.5%, and you have a volume of solution that's 100 milliliters times 100%, what's this mass? So we'll solve for mass. A mass is going to be the percent weight per volume divided by 100% times the volume of solution. Okay, so I've taken, to isolate mass, I have to multiply both sides by volume of solution and divide both sides by 100%. That'll get rid of these and put them on this side. So here I've got 1.5% divided by 100% times 100.0 milliliters. Now this is a little bit of a special case because it's 100 milliliters. This is going to be 1.5, and we're talking about weight, and since this was in milliliters, this will be in grams, so 1.5 grams, because grams of water are related to 1 milliliter. The next case is going to have the same sort of an arrangement. So we want to know what the mass is, and we know what the volume of solution is. So we're going to still rearrange the same way. The mass of the solute is going to be equal to percent weight per volume divided by 100% times our volume of solution. But in this case, we don't have sort of the convenient number of 100 milliliters. In this case, we've got 0.50% volume per volume. So in volume per volume, both of the things are going to be in milliliters or the same kind of units. So 0.5% volume per volume divided by 100% times 25.0 milliliters. So my answer should be in milliliters. So I'm going to have to take my 0.5 divided by 100% times 25. This gives me a pretty small number. 0.125 milliliters of the sulfuric acid is in that 25 milliliters. Well, this isn't a big volume, and this is a small concentration. So this is a small amount of solute. The same concept is going to be applied now, but in this case, they've given me the mass of the solute and the percent. So if you've got your percent weight per volume equals the mass of the solute divided by the volume of solution times 100%. In this case, I've got this, I know this, and I know this, but I don't have volume of solution. In this case, I need to isolate for solution. And so what I'm going to do is multiply both sides by volume of solution. And that's going to cancel these out. And what I get is volume times percent weight per volume is going to be equal to the mass of the solute times 100%. That gets me my weight per percent up here, and my volume is now out of the denominator. So what I have to do now is divide both sides by percent weight per volume. And that's going to leave me with volume equals the mass of the solute times 100%, times the 100% divided by your percent weight per volume. So my volume is going to be the mass, which is 3.0 gram, times 100% divided by my 1.5%. And this is going to give me 200 milliliters. So does this make sense? 200 milliliters at 1.5% has 3 grams of solute. Yeah, that makes sense, right? If it was 100 milliliters, we'd have expected 1.5% to have 1.5 grams. Now, important to remember that we've got grams, so this has to be milliliters. Down here, we're going to use this same rearrangement. V equals mass of the solute times 100% divided by your percent weight per volume. And so I had to do the rearrangement to get to this. But my mass, this is volume per volume. So it's not going to be mass, it's going to be volume of solute. In this case, it's 10 milliliters of solute. So it's going to be 10.0 milliliters times my 100% divided by 2.5%. And so in this case, I'm going to have 10 times 100 divided by 2.5. And this gives me 400 milliliters of solution. And if you weren't sure, you could always just plug it back into our original formula, which would have had percent volume per volume equals the volume of solute divided by volume of solution times 100%. And if you plugged this as your volume of solution, and this is your volume of solute, it'll come out to 2.5%. So you can always check it if you weren't sure. This question, we're going to calculate the mass of the following quantities and concentrations of solutions. So here they've got 3 liters and 35% of hydrochloric acid. So then the percent weight per volume equals the mass of solute divided by the volume of solution times 100%. And so in this case, they've given me the volume, they've given me the percent, I need to calculate this. So the mass of the solute is going to equal percent weight per volume times the volume of solution divided by 100%. And so the mass of the solute is going to be 35% divided by 100% times 3.00 liters, and that's going to give me 35 divided by 100 times 3 gives me 1.05. Now this is liters and this is weight per volume. I said that 1 milliliter of water is equal to 1 gram, but also 1 liter of water is 1 kilogram. And since this is in liters, this is going to be in kilograms. This final example gives me a volume of 99.5 weight per volume of this chemical, and I'm pretty sure this is acetic acid. So they've given me the volume of the solution, and they want the mass of the reagent. So we've got of the solute. So the percent weight per volume equals mass of the solute divided by the volume of solution times 100%. So again, we're going to try to find out what that weight is. So the mass of the solute equals percent weight per volume times the volume of solution divided by 100%. And this is going to be a very large percentage because there's 99.5% of it they're saying is solute, which is a bit ridiculous, but that's fine. At that point, really, water is the solute, but let's not get stuck on that. 99.5% times 50 milliliters divided by 100%. Well, it's going to have to be pretty close to 50 milliliters because it's 99.5%. So we come out with 49.8 milliliters. We only have 3 sig digs, so I've had to round off. That's how you handle these percent weight per volume and percent volume per volume questions.